In this example, we're going to look at solving an equation that has a variable in the exponent on both sides of the equation. Fortunately for us, this doesn't change a lot of our work as it relates to logarithms, but it will change a little bit of the manipulation that comes when we're trying to solve the equation. So our first goal for solving any exponential equation like this by using a logarithm is to isolate the exponential part. I don't really have that option because there are two of them, but at the very least, they're by themselves on both sides. There isn't any extra term or any extra multiplication to worry about. Each one of them is by itself. So I can jump right in with using either the natural log or the log base 10, both available on my calculator, to simplify this equation and rewrite it. I'm going to use the natural log. So on the left-hand side, I'm going to take the natural log of 2 to the x plus 1. And on the right-hand side, I'm going to take the natural log of 5 to the x. We use our power rule again, bringing down this power. Very careful to write it in parentheses because that entire expression, x plus 1, is now getting multiplied by the natural log of 2, and then bringing the x down on the right-hand side. My first objective is accomplished. I've gotten the x's out of the powers. Now I move to getting all of the x's to one side. In order to do that, I'm going to multiply out the left-hand side, and then I'm going to start moving some terms around that are going to allow me to get all of those x's onto one side. The easiest way to do that is to just push this term that way, and I rewrite my equation like this. I subtract that x ln 2 from both sides. Remember, natural log of 2 just means it's a number. It's an exponent of e that gives you those outputs. It's not anything beyond just being a number. So that term can be moved around just like we would move around any term like 3x or 5x or anything like that. I'm going to factor the right-hand side to turn my 2x's into 1x, and that's usually the step that gives people the most difficulty, remembering that you're allowed to do that. And then this, remember, is just a number. That is just a number. So I have a number times x. I need to get rid of that multiplication. I'm just going to finish by dividing. So my final result is x is equal to the natural log of 2 over the natural log of 5 minus the natural log of 2. If I want to approximate that, it's about 76/100ths. I can back substitute that and make sure I get the same amount on both sides, and I do. So the presence of an exponential on both sides of the equation doesn't really change our problem-solving process much. It allows us to use the natural log or log base 10 on both sides, bring those powers down, and solve as I normally would.